I'd like to welcome you to the Geological Society of London and to what is the 8th of the London Lectures for 2014, entitled Geoheritage and the UK's Most Significant Geological Sites. My name is David Manning. I'm President of the Geological Society of London, and it's a great pleasure for me to introduce tonight's speaker, Professor Rob Butler from Aberdeen University. This talk this evening coincides with Earth Science Week, and it coincides with the announcement of the result of the Society's 100 Great Geosites project, which is designed to showcase great outcrops, inspirational places, and some of the geology that underpins our cities and great engineering prospects. As anyone who has studied geology knows, Britain and Ireland possess a unique variety of geology in a very, very compact space that's manifest in spectacular outcrops and diverse landscapes. And I'm sure we've all been stimulated by going to have a look at those. Some of these have been fundamental to the development of geology as a science, and they tell stories of scientific discovery and the deduction of Earth processes. They tell us how science has developed. There have been centuries of endeavour, and even so, the outcrops which we're so familiar with can stimulate and inspire new fundamental research, and that's one of the beauties of our subject. And very importantly, they're stimulating the next generation. They're there to act as classrooms for students of all ages, and particularly young people coming into the subject as we once were ourselves. And they're shop windows that everyone can enjoy and appreciate for our science at large. Now, as you'll hear this evening, the heritage that we have is not entirely safe. It's under threat in a time-honoured fashion. And it's under threat not only from developers, but by insensitive environmental protection, where well-meaning activities might cause problems from the point of view of the geological heritage, and indeed ecological restoration. So those are issues which are important for us to bear in mind, the conflicts that might arise from different ideas about land use. And then, more disturbingly, of course, is the damage that has been done and perhaps continues to be done by professional geologists who destroy sites through unethical sampling, and in particular rock coring, and I'm quite sure that most of us have seen the evidence of that with our own eyes in the field and how destructive it can be. Turning to our speaker, Rob Butler is an enthusiast for field geology, and he's very well known for his research in structural geology, particularly the structural geology of thrust belts and mountain systems in general. His 30-year career began in the Northwest Highlands of Scotland and has since spread to include the Western Alps, the Apennines, the Himalayas and New Zealand, with stopovers in Lebanon, Oman and other parts of the Mediterranean. He has lectured widely on these aspects to public audiences and was featured on BBC's Men of Rock series exploring Britain's geoheritage. You're all waiting now with bated breath to see the nature of the beast. Rob has occupied the chair of tectonics at the University of Aberdeen since 2008. Before then, his career took him through the University of Durham, the Open University and the University of Leeds. He's chair of the Geological Society's Geoconservation Committee and a passionate advocate for using outcrop geology to convey stories of Earth processes. Ladies and gentlemen, please welcome Rob Butler.
Good evening, everybody, and thank you for taking the time to come in on this damp evening. Yes, and thank you for the introduction, David. What I'd like to do over the course of the next 50 minutes or so is take you on a bit of a tour. The key word to start with is variety, and as David pointed out in the introduction, the geological heritage in the UK for the sort of surface area of the islands of Britain and Ireland is probably unrivaled anywhere on the planet. And that not only is a great heritage resource, as we'll see, it's also impacting on a whole bunch of other areas of society. So we're going to go and have a look at that. So what are we going to cover over the next little while? Well, I'll talk a little bit about the geoheritage underpinnings, and then spend some time talking about the 100 Great Geosites project that the Society's been running for the last 6 or 7 months. The results of which came out on Monday. And then I'm going to take a bit of a personal tour through some of my favourite places that are relevant to the sort of science that I get up to. And And that will lead into the conservation challenges, which are not necessarily particularly evident. Some of them are, but there's some insidious ones that we need to get to grips with. And at the end, rather than finish on that sort of challenging note, I'll talk a little bit about why the field geology is still really important, and that which comes in at the bottom there. That at various stages through my career, as various of my colleagues in other parts of the university sector have been saying that geology is essentially a 19th century, field geology is a 19th century sort of topic, and we know we've learnt all we can from the field, and it doesn't serve any purpose going there. And I think I've seen a few shaking heads around the audience already as I've said that, and I certainly do not believe that, quite the opposite, and it's something I want to talk about as we go through at various times. So let's crack on. So why do people become fascinated in geology? And it's probably from, at least in my case, and maybe for many of you in the room, it's stumbling across with an uninformed eye bits of curious rock sculpture, rock landscapes and rocky outcrops. And the first question you ask is, why? What's that? And it triggers curiosity as to why you get these strange landforms. A couple of outcrops in Yorkshire there. And it's exactly the same questioning why that underpins our science, of course, and you can start that discussion in terms of UK geology, perhaps with the work of James Hutton. Of course, if you're Italian in the room, you might say you need to go back to Leonardo and rather than to Hutton. So each culture has got its own birth and parent of our science, but Hutton's a good place to start for us, because these outcrops at Sicker Point and up in the highlands around Glentilk are actually fundamental to understanding Earth process, and more critically, I think, more critically even than that, was the fact that fed directly into the Enlightenment movement in Edinburgh, which basically challenged conventional thinking, so underpinned and actually drove a whole bunch of intellectual endeavour that mapped onto a whole bunch of areas of human activity way outside geology. And the geology is right at the forefront of triggering that sort of non-conformist behaviour, the iconoclasm that sort of goes with that. So you can start, that's really important. I think we'd all agree that sort of thing is fundamental to our Earth heritage. And there's a whole bunch of other things that are recognised as part of our heritage, including World Heritage sites within the UK and Ireland that have got a very strong, if not fundamental, Earth science component. And the Jurassic coast along the south coast of England and the Causeway coast in Antrim are clear examples of that. But we can step away from those ones to other sites that are recognised through the Geopark Network within Britain and Ireland and beyond, but certainly within Britain and Ireland. And then the spectacular set of outreach opportunities we have through the network of museums, local museums, big national museums, and the geological centres that describe our science to the public. And I've just picked one of those, the Art Dynamic Earth Centre in Edinburgh. So there's a whole bunch of these things that are there and attractive to people who know nothing about our science. There's also a whole bunch of our heritage that frankly is not very pretty, but is also fundamental to what we do as a scientist, and is important to get out to the public. And you can start with the extractive industries for a start. So from coal and oil. The oil industry is very, very, very poorly represented in terms of outreach and museums to go and understand that. There are a number of ones that try and explain the importance of coal as a fossil fuel to society, based on abandoned pits around the country. And similarly, the metals industry in Cornwall, the Geeble tin mine has got a visitor centre. You can go underground and experience, at least to a small extent, what it was like to actually try and work in there. A very small extent, it has to be said. And you can also go underground and look at the technology associated with the pump storage system at Denoric and other places. So there are outreach opportunities there. You don't have to go and scuff around really, totally unpleasant places. But nevertheless, I think then it's a story that we haven't told enough to society about how geology underpins so much of what we do. And you can make that case even more so, if you like, in the engineering world. And I've got two examples from different parts of humans' history on these islands. The Channel Tunnel, the diagram from Wikipedia. I thought I'd just go back to elementary sourcing of images, but just that image shows you how important the geology is for the boring of the Channel Tunnel, because the tunnel sits in a rock formation, part of the chalk, that is appropriate to the geotechnical properties of the tunnel, and it was essentially cut with real-time paleontology to make sure that they stayed in that formation and didn't go one side or the other. So it's essentially directional drilling for transit systems, and is clearly the geology controls where the tunnel goes. Don't know the geology, you're in big trouble. So, and the same is true for bits of archaeology like Skara Brae. The Skara Brae works as a bit of engineering, bit of building, because the flagstones there are easily worked and broken into brick-shaped pieces, so you can make buildings out of them. It's a similar sort of intellectual exercise. We'll come back to this as we go through the talk today. Well, recognising that range of the way in which science works for our society, the Geological Society over the last several months has been engaged in a project called the 100 Great Geosites Project, the results of which were published this Monday. How many people in the room were engaged in that? How many people went on Facebook, voted, etc.? One or two? Don't be nervous there. It's quite interesting because you're here listening to this talk, so it's clear, unless it was too wet outside and you wanted to take cover and just hear randomly, this continuous subject of interest. Well, let's. How does the project work then? So over the summer, there was, through social media, there was a call for nominations of sites. Places that people were particularly attached to, examples of engineering, anything like that. And there over 400 nominations came in to the society through Facebook and Flickr and so forth. On the back of that, the team put together a listing under various headings, more of that in a very, very short minute, which allow people to vote. The intention being to generate a list of public choices of what they thought that to generate this 100 sites result. In addition to that, a bunch of us got together to make sure that there were no obvious, really important sites, if you like, that fell through the net. So there was a sort of component, partly public voting and nominations, partly a sort of a professional expert group as well. On the back of that, on Monday was the publication of the results, and the sites are grouped into 10 categories, which are listed there, and each has 10. Has 10 sites as part of it, making 100. And the people's choice in those has, we'll come to in a minute. Now, the interesting thing, this has generated a pretty major media storm. At least it's by quite a long way the largest media activity the society has been engaged in, actually, and which is quite surprising. So it's captured the imagination because it's a list, I guess, and it also looks like a countdown. And the fact that it corresponds to the same week in which The Apprentice has started round again may account for that sort of competitive nature. Unfortunately, our intention was that the numbers associated with each site were just a reference number. So if you're number 83, it just meant you could go to it. However, the media view it as actually that's the 83rd best site. And actually, it's referred to, we deliberately called it great sites, not the greatest sites, not the top sites, so that actually it's not meant to be an exhaustive list. But nevertheless, the media are referring to it as the top sites. And that's fine. Ish. Now, it does mean that many of these places can actually market themselves and do a lot of publicity, which is great. We'll come to that in a minute. And you can go and check them out. I skipped through the slide, but there's an interactive map. You can go and find out what they all are. And I've already had a bit of complaint about one of the sites which has no business being there. I'll leave you to check what that is. So let's go round through the list. And because the landscape is the top there, number one nomination, therefore, number one is here, and is Assynt, the Assynt Mountains in northwest Scotland. Fantastic landscape, very dramatic, geologically stunning. You've got the oldest rocks in Britain that is more or less that forms the low ground in there. Crust formed 3-ish billion years ago, reworked about 2.5 billion years. These hills, the Torridonian sandstone there, 1 billion years old, all sculpted by ice sheets over the last few 100,000 years. So it's a great place to tell geological stories. and a nice place to visit. The industrial economic importance, number one, people, these are the people's choice, so it's not just us in the society, by no means that we voted, of course, but there were 1,200 other people who voted. The Iron Bridge Gorge. Now, in the media coverage I've been dealing with, people said, huh? It's an iron bridge. How, apart from the fact the iron's obviously a geological material, the fact is that Iron Bridge Gorge, the cradle of the Industrial Revolution, is there because of coal and iron ore. So it's the earth resources are why it's there as an important site and why the Iron Bridge was built. And that coupled with the Severn, which is a transport system to be able to export your products. So that combination of geology is why it's there. It's why the Industrial Revolution happens in Britain. If we didn't have the earth resources, well, we wouldn't have happened. So geology underpins the last 300 years of development in Britain. Historical and scientific importance, that was to the subject. Those of you, well, actually I'll come to it in a minute, but I think this is, for me, probably it's probably more important, I think, to 20th, 21st century humanity in Britain than Stonehenge is. This is for the Enlightenment movement issues that I spoke about before. That really important site. I keep doing this is clipping off. Died last time at this point. The education number one is the Rotunda Museum in Scarborough, a great example of the network of regional museums in Britain. This one designed by William Smith, one of the very earliest purpose-built museums to display geology. It does great outreach today. There are 5,000 people turned up over a weekend in September to go to the Fossil Festival there. It's an interesting timing because maybe a few of them might have voted for this site, which is why it's the people's choice. But anyway, but it's great. Good luck to them. They do outreach. That's great. So a really important site. Rather flippantly, we decided that we'd have an adventurous site, so places that you have to go a little bit harder to get to. So Stafford, people's choice in our adventurous category, you had to go sea kayaking to get there. Other nominations in there included things like Gaping Gill in the cavern in Yorkshire, where you have to abseil down something the size of St Paul's Cathedral to get in, which is also an example of adventurous. Stafford was the people's choice. Stonehenge was the winner of the human habitation site, and again in the media coverage, people said, huh? Why Stonehenge? Well, that's built on chalk, okay, bedrock chalk, probably about the worst building stone in Britain. And so in order to make big monuments like that, you're going to need to get proper stones. 5,000 years ago, they realised that, so they went to Wales to get their stones. That's geology engineering. And so that's why it's there in our list, and it's the favourite habitation site. The favourite coastal outcrop were the cliffs at Hunstanton, or as my sister tells me, I should say Hunston, if you come from that neck of the woods, but nevertheless, Hunstanton for me, and everybody else I've spoken to. The favourite coastal outcrop in our listing, and a great geological story because it tells of the invasion by the late Cretaceous sea across Britain, as there's very little sea ice on the planet, there's very little ice on the planet at that stage in a warm time. It tells of climate change. And a great place to sell geological stories. The favourite outcrop was Craster in Northumberland, not that far away from where David Manning hangs out these days. And the outcrops you've got at the back there, a great outcrop of the Windsill, goes inland and obviously underlies Hadrian's Wall, an interesting political feature these days. So. The next category were folds and faults, topics close to my heart, and more of these are going to feature as we go through the next little while. The favourite fold and faults outcrop, the outcrops at Mullock in Cornwall, just south of Bude. These fantastic bedded sandstones and shales deposited under deep water, crumpled up during the Variscan orogeny. These folds you can trace all the way along the coast, the North Cornwall coast, up into Devon, all the way up to Heartland. A spectacular set of rocks, and they're a really excellent example. The fire and ice winner was Glencoe, and it does both things because it tells of volcanic processes, the rocks there, and also the sculpting of that landscape through the actions of ice over the last few tens of thousands of years. So that's the top 10, the top 10 as far as the media is concerned, the 10 public choice in our great list. 4 of those are from Scotland. little points here out of the 10. 34 of the top 100 are from Scotland. Now, I don't have a problem with that. It's not like we drew this up with a Barnett formula in mind. But that wasn't how it was viewed by the Telegraph on their website, who obviously had a quite an amusing line here. To be fair, Westminster Abbey does feature in the 100 list because of the building stone, the fact it's on the crossing, for the historic crossing on the River Thames, so it makes a lot of sense. But they somehow thought that, yes, it should be a winner, and that's fine. Interesting take. Anyway, what I'd like to do now is with that is now go and look at why these things are important. And for me, I'm going to concentrate on the field side of this rather than the industrial and built environment side. And for me, the really key part of this is about building a narrative, and you're never too young to start geological mapping, wielding a compass and a map. It's about sharing experience, and what you've seen there in the student group there is they're doing a group exercise on a field location, which we're going to visit together shortly, and they're sharing and building stories about the rocks, and the rocks are inspiring them to talk science. That is why it's important. So let's go and have a look at some examples of that and try and track through some of my favourite places to actually do some Earth process and tell some Earth stories. So let's start off on Skye. So Skye, let's start, is a historical important place. The place that you're sitting now, this room, used to be a debating chamber. It still is a debating chamber, but at the moment you could be fairly passive and dozing off while I'm talking to you. In bygone times, and some of you may remember it, I don't, it was before my time, this was set up much more like a parliamentary arguing debating chamber. Two former presidents of the society back in the 1890s had a huge argument about that geology. The hills on the right are granite. They're part of the Red Hills of Skye, if you know the ground. The craggy thing on the left on the skyline, there's the southern end of the Coolins, effectively, and those are gabbros. And there's a big argument about which of these rocks was younger. And of course, being igneous rocks, you can look for cross-cutting relationships to tell that story, or to see what was going on. And outcrops like this on the skyline up there, that our student party is running away from as fast as they can, up on here, shows white rocks, the granites, intruding the gabbros. And it's dead easy to see. That argument was supported by, or was the argument of Archibald Geekie, and he basically disproved Judd, who had the other relationship, and Judd had to basically leave the field with his tail between his legs, and yes, came out of it rather poorly, particularly considering how obvious some of the field relationships are. Sky's the Coons of Sky are one of our adventurous sites, and I thought I'd put this in because if you haven't seen the programme, it's absolutely staggering. So Danny McCaskill is a very great mountain biker, and if you want to see mountain biking at its craziest, go and watch this programme. It was broadcast in BBC Scotland over the weekend and is on the iPlayer at the moment. Not only is it a place to get very nervous about crazy behaviour on bicycles, it's actually the aerials of the Coolins are stunning, shot by an octocopter clone, a drone, and it's actually a great use of a drone rather than flying Albanian flags across Belgrade. So it's a great, go check the video out. Now if you go to elsewhere on Skye, just come away from the Coolins, those misty hills in the back, you can actually start doing some other things and start talking about science that's relevant to solving problems now in the 21st century. And what we're looking at here are a dike running through the middle of the picture, intruding Jurassic sedimentary rocks. And they're great, spectacular rocks, and they're telling a story of rifting and of pulling the crust apart during the initiation of the formation of the North Atlantic. So here's our students gazing at an outcrop. Here we go, and that's what they're looking at. And I asked the question, of the two rocks, the black stuff and the pale stuff, which do you think's the igneous rock? Well, it's obvious, isn't it? It's the black one, it's intruding. That's the igneous rock, that's the basalt, that's the sediment. Okay, so what's going on in here? Well, this is the interpretations. The story that I would convince you of is that the magma is getting into the sediment and quenching and shattering as it does so. creating cavities, and the sediment is injecting in. I'm deliberately using the word sediment, not sedimentary rock, for the condition of that material must have been like ketchup to have squirted in. It wasn't lithified solid rock. Now that's key, because the age difference between these units is approaching 100 million years. So for about 100 million years, the sediments were not lithified. They're staying as gloop. Now that's kind of important. Understanding the way in which magma interacts with sediment is key, because not only just because it understands that outcrop, but actually that's a really critical issue if you're trying to understand areas like the Faroe-Shetland Basin, an area of active hydrocarbon exploration. Understanding how heat is distributed in that basin, what the state of the sediments are from time to time, is really important if you're trying to explore for oil and develop that as a resource. So it's fundamentally important now. So let's go and look at another outcrop. Here we have a similar sort of situation. If you like, a black seam apparently intruding this rough stuff down in here, which are gneisses. But this isn't volcanic at all. These are frictional melts on faults, things we call pseudotacholites. And these really spectacular rocks, again with these intruding wings, are telling us something really neat, because you just think about what you have to do to melt a rock by friction. You have to move it really fast. So the only ways in which you're likely to do that on a fault is by an earthquake, and a big one. So what you're looking at here is essentially a frozen earthquake. So understanding active faulting, you go to places like this to see the products of those processes. Otherwise you don't see them, they're 10 kilometers underground. So this is a great place to get insight on the faulting mechanism. These outcrops on North Dearest, on the Outer Hebrides, really important, and one of the recent medalists of this society, Rick Simpson, did a lot of really fundamental work describing how these systems work. But my favourite fault in Britain is actually this one up here, up on the north coast of the mainland of Scotland, up near the village of Durness, where you get these really neat big fault scarps heading out into the North Atlantic. Let's go and have a look at them in a bit more detail. No, it doesn't. Right, so here we go. There's the fault plane. Look at the fault plane, and it looks like it's pebble dashed. Little bit of a 5p coin there for scale. Those are broken grains of the surrounding material, broken by movement on the fault, angular fragments. But actually there's more to it than that, because if you look at it, first of all, it's not falling apart. So it's not just a bunch of gravel falling down. It's making cliffs, and it's cemented by that white stuff, which is precipitated calcium carbonate. And if you look even more closely, you can see that some of the lumps in there have actually got broken white bits in it. So it's telling you that the cementation process is happening, and then it's breaking again. So it's synchronous with the break, seal, break, seal, break, seal, as this fault has moved. It's telling us a lot about how fluids move on faults as they are moving through their dynamic history. So you can understand a bit about the faulting process. And it's an example of one of the many great faults around Britain where we can understand fault processes in some detail. So where did that stuff begin? Where did we get into looking at faults in detail? Well, actually, it wasn't just a few years ago. Let's go and look at where it began. Up here, just along the way from Durness, a little bit further to the east. A place called Benarnable, and it was actually part of a bunch of debate, another thing that was shouted out in this room when it was a debating chamber, a thing called the Highland Controversy, which was about understanding the rock sequence in landscapes like this. The place it was resolved is the top of that hill. This is the outcrop, where you've got, well, hey, now let's get one of the protagonists to explain it. This is Archibald Geekie, former president. He's already been lurking around in Skye. Okay, so when a geologist finds nice, gently overlying inclined sheets of fossiliferous quartzite, shale and limestone, in this case just the quartzite, he may be excused if he begins to wonder whether he himself is not really standing on his head. Which, yes, in terms of, it's also a commentary on the gender balance in Victorian science, but he assumed only the men would be looking at the rocks. And, but nevertheless, what you can see here is an inversion of what you'd expect to find. It's upside down. You've got the older rocks, the basement, sitting on top of the sediments. Now, the irony of this, irony of this is that Geekie was on the side that this should be normal sequence of rocks, and he was adamant that was the case, and it was only really shouted down by a guy called Charles Lapworth, who understood what that was. And Lapworth said that there was a major fault there that was doing the business. And then Geeky came along and said, oh, that's right, let's call them a thrust then. And he published it in Nature. But for a while, he's got the credit for it. But enough of the political side of that. But what Lapworth also did was set the hair running in understanding fault zones. So this is Lapworth's, well, it's my photograph of Lapworth's outcrop. Forget the white streaky stuff, that's lichen. Look behind that and you see the rocks are quite streaky going through, and that's because they're recrystallized during the faulting process, shearing out, making a new material which we call a marlinite. And Lapworth described all that in 1884-85. And subsequently, it's from that basis that we started looking at faults from a microstructure and a dynamic entity. So it's where it all began. So a really important site for the history of science, which is why it's in our 100 Great Sites list. I should have said that every time you see that little logo in the bottom, it means the place I'm showing you on the slide is actually part of the 100 list. Let's go on to folds. Folds are probably more obvious than faults. You know, Geeky, before his road to Damascus conversion to thrust faults, actually was probably quite happy recognising folds in the landscape, and because they're kind of obvious. So if you want to really go and look at folds, yes, you can go around to Stackpole, but probably one of the best places to do it is a little bit more remote, in the middles of boondocks in Gnesha. Here we are, on the shores of Loch Monagh, one of the reservoirs in the middle of that countryside, and it's truly spectacular. Just take you, let's go on a little tour of some of the fold structures we can see there, where we've got fantastic, these are Fermat Sandstones, now metamorphosed and then folded. So you get these really spectacular shapes, but it's more complicated. They were nice, but you get patterns like this. We've got an egg crate, looks like an egg crate, doesn't it? Looks like looking down on an egg crate, which is sort of what the layers are doing. And they're forming by being squashed one way and then another. So we can begin to get an idea of complex polyphase deformation, and John Ramsay did a load of fundamental work on this in the 1950s, which basically established how we understand polyphase, polydeform rocks. And you think, aha, they form in the middle of mountain belts. Great. Well, let's go and have a look at some others. And here we are in Cromer on the North Norfolk coast. Not a mountain belt in sight at all. I'm quite surprised to have found myself there to even taken the photograph. And so that stuff there are not polydeformed metamorphosed rocks. That's gunk left by glaciers over the last 100,000 plus years or so. Okay? You go and have a look at those cliffs, and these are the patterns you see. The layers contorted, refolded. You might see something there with a slightly dodgy shape coming around like that and bent over on itself. Okay, so it's refolded, polyphase deformation, and it's being done by glaciers, ploughing into their own detritus. Understanding this deformation is kind of important because it's telling you that the glaciers are overriding their own detritus as they're building out. And that will impact on how far a glacier can move. Essentially, it's lubricated by its own muck underneath it rather than grounded on bedrock. So the ideas are ice sheet dynamics evolve if we build these types of interpretations and observations into them. Let's get back to my comfort zone and get back up to the northwest of Scotland. And because we can do more than that, let's go and look back at how the continental crust works. We can use outcrops up there to do really fundamental things about understanding the crustal underpinnings of these islands. Great place to do that, a place called Scary Moor up in Sutherland. So here we go, and we take our students, many people take their students there. Let's go and see what they're finding. So we can find rocks like this. Here they go. It's that pink stuff heading out to sea, and those slightly about to be rained on students over there are looking at the continuation of this stuff. And those pink colour patches, those are single crystals. Patches of felspar, the size of this stage. You go and have a look at them, this is what you see. Textures you would otherwise see down the microscope. That is something called exsolution. What that means is there's too much silica in the felspar, and as it cools, it comes out of solution and recrystallizes on the cleavage planes in the mineral. And that's what you'll see, forming that shape, and you can see the other cleavage planes running through like that. So you can actually see, you can show students without having to go down the microscope, you can actually see the product of those processes in outcrop. So what else are they seeing? Here they are, about to do a backflip into the minches, and what are they looking at? stuff like this look like sort of blackcurrant fruit pastels, doesn't it? These really spectacular rocks in here that are originally basic in composition, igneous, but now metamorphosed, really spectacular textures. That cluster of red material, which is garnet, so the black stuff is orthopyroxene, that is about the size of a 50p coin in there, and putting those assemblages together, you can tell that rock is very dry and has been down. It's achieved that assemblage of minerals at about 30 kilometres down in the crust. So it's been down, it probably formed down there, and that's where it was metamorphosed, and now it's back at the Earth's surface. It's got there, it's at the Earth's surface, we can observe it. On its way up, it changes, or some of it does. So some of these garnets, the pink bits in there, get these rims of reaction products, which are hydrous minerals like epiderm, that are recording the hydration of the crust as it comes back to the surface. And you can put that together with field relationships like this. The pink pegmatite, you can still see the crystals sitting next to my colleague in the red there over the far side of the slide. You can see that these are the fruit pastel rocks on the side, and the students can put it together from the cross-cutting relationship. So over a matter of hours, you can do some really fundamental geology about how the crust works, how it formed 2.5 billion years ago. Just to complete some of that story, cross-cut by later dykes. We've seen cross-cutting, we've seen dykes before. We saw them, 20 minutes ago at Elgol. The ones at Elgol, where they had all that shattered texture, they're, 55 million years ago old, those ones? These are 2 billion years old, cutting through the crust. So we can build a story of deep geological time as well. So some pretty neat outcrops in the far northwest of Scotland, notwithstanding the scepticism of the Daily Telegraph. So a great place to go and see some rocks. But I've really given the story so far with a slight distraction going off talking about Faroe Shetland. Let's go and look at how we can use some of these lessons to do more applied geology, why it's important to the sort of financial future of the UK in terms of economic impact. So here we've got a group of students, but these are from industry, from various companies, gazing out across, again, one of my favourite outcrops on the north coast of, it's about an hour from where I live, actually, looking out onto the Moray Firth over on the left there, the water on the left. Let's go and have a look at the outcrop a little bit more carefully. And there it's nicely lit. Those are dune sandstones of Permian age. I've replaced the oil company geologists with a bunch of our students now, just because the sun's come out. And you can see the great big dune sets in there. Those are dune sandstones. They're a fantastic analogue for what a rock formation that can contain oil is. It's a highly porous rock. And so it's a great place to go and make that point to people and say, what's a hydrocarbon reservoir look like? Stuff like this, big high porosity material. But actually, look a bit closer, and actually the reason that I'm talking about this is there's a whopping great fault running through it that forms the left side of that cave, and it actually comes through to form these outcrops at the front of the beach here. Let's go and have a look at that in a bit more detail. And there's this, you can see there's a sort of Brownie Stain bit here, which is the main fault zone, but it's not just that. Off in the main sandstone over here, you've got these tiny little faults. Now these are kind of neat, because what the faults do is they repack those sedimentary grains, destroying the porosity a bit, packing the grains a bit tighter. So from a performance of what this would do, if you were trying to move fluids from one side of this outcrop to another, which you might try and do if you're trying to produce hydrocarbons from this, these seams, so-called defamation bands, would really mess you up. So understanding that fault zones aren't knife-edge, simple, bang, but actually have got all this halo of damage around them is really important if you want to try and understand how they will work in an oil field situation. Similarly, it'll be a really important thing if you want to push CO2 into these things and do underground storage of CO2. So any fluid engagement in these things, you need to understand the structure. Let's go and have a look at another one of my favourite places. We'll move away from Scotland for a minute or two again and go down to Pembrokeshire. Really nice place, a very popular place with student parties again, groups I should say. And make the point that these help us interpret the subsurface. Just like on a small scale, we can understand how at Clashak what might be going on. Here, outcrops are informing the relationship between folding and faulting. Under what situations might that be important? Well, let's say probably not in the North Sea area, but if you go to other parts of the world, for example, 3-4 kilometres underwater in the deep part of the Niger Delta, which is where this seismic comes from. Scale's somewhat different, so you're probably looking at a vertical 3 kilometres or something like that on the scale in here. But you can see a series of folds and a series of faults, although actually you're interpreting the faults, you barely see them. What's going on in those zones? Well, how much is it going to bet? What stake are you going to put on the table to actually go and find out? Well, probably $500 million a well. So actually having some idea of what you might be going into and what the uncertainty is between folding and faulting actually has a really big economic message there, because it's going to cost you a lot of money to actually go and test your bet. So outcrops play a really big role in trying to think about what's possible. So you might think, a bit complicated, I might walk away from this one for a year or two and go and drill somewhere else. Right, so we can understand process and we can apply it, but what about the general training value of these outcrops? As I mentioned at the start of it, field geology has had over the years a slightly bad press, and field mapping in particular is thought to be a 19th century activity, and we shouldn't be teaching it in some communities. Well, actually, fair enough. People aren't going to become a practicing field geologist. You're not going to, I don't know how many people are employed in the UK to make maps, but I'm using outcrop geology alone, but it's probably one, and I may be overestimating that number. So not many. But what the point is, it's about visualization. We teach people to map because it's about visualizing what's going on. If you want to understand, I will pick it up. This is full of, this was empty, that was quite lucky. If you understand what that looks like in 3D, you hold it and walk around it. It's much easier than taking a photograph or even making a 3D model and then displaying it on a two-dimensional computer screen. You want to experience it in 3D to understand what it looks like. And the same is true for geology. So we take people to areas of great big outcrops so you can actually move around and experience the whole thing. So you can walk around this outcrop. It has historical importance. It's where Charles Calloway thought that was, in the 1880s again, thought there were big thrusts. He walked around it to see whether it was the same on the other side, effectively, and make a bit of a model. But our students can do the same. So you can walk around onto the front and see the same thing diving back underground. You can use it to make maps. This is the survey map based on the mapping in the 1880s, to show the rock layers going in and out of the fields either side of that, round through that landscape. So you can begin to appreciate the 3D. Why on earth? You don't find oil in cups. So why might you need to do that? Well, let me show you some modern 3D data. It's actually from the same place as the 2D seismic we looked at just now, more or less. And it shows some 3D seismic data interpreting the pattern of faulting and geometry of the layers in there. You need to think in 3D and do it. So that's why we teach our students to 3D thinking, to interpret geology in 3D. And it's not just the oil business that does that. If you want to understand what water looks like in an aquifer or pollutants entering into it, that's a 3D problem. So we map to build 3D models. Yes, we can run around the field with a map and compass. You can actually download an app and put it on your iPhone and run around and do it as well. But you're still mapping and experiencing the landscape in 3D, landscape like that. So this now leads on to the serious bit, if you like, which is the conservation challenge. Now, in Britain, it is in Britain at the moment, primarily, we have a fantastic doomsday book of great geology. It's a thing generated by a thing called the Geological Conservation Review, which was started in the very late 70s, early 80s, by the JNCC, the Joint Nature Conservancy Councils, and by the now devolved organisations such as Scottish Natural Heritage and Natural England that actually look after that business. Now, there are about 3,000 within England, Wales and Scotland sites that are Geological Conservation Review sites. In Scotland, they're 850 odd, 895. Now, these are really important sites. That's how they're defined. Those sites of international importance needed to show all the key scientific elements of the Earth heritage of Britain. I've hardly touched on any, I haven't I? 3,000. Even the 895 in Scotland, we've just seen half a dozen. But they're a lot, and they're really important. So you'd think they'd all be SSSIs, Sites of Special Scientific Interest, conserved in the same way as if they were native woodland or bog or something. So, but not. Yeah, in Scotland, of that 895, 204 have yet to be designated as SSSIs, 23%. That's a huge risk to that resource. Now you might think, well, that's okay, it's okay, as long as the really good ones are okay. And actually, the only development threat are in urban environments, like if it's an outcrop, near Glasgow, about whether they're going to dig it out of the ground or build a house over it. But actually, a lot of the conservation challenges are in places like this. How on earth could Assynt in northwest Scotland have a conservation issue? They're not going to turn that road that goes out to Loch Inver into a motorway. I mean, that's not going to happen. So it doesn't look like it's going to happen. It's a big issue because this is the landscape you want to preserve. To make maps, you have to get over the landscape. You have to be able to trace out behind that old ruined building some folds. We'll look at them again in a minute. If you can't see them yet, well, you'll maybe see them in a minute like some graffiti. Let's look at what that. You can even see some of this stuff in the grain on a satellite image from Google Maps. It's that ruin wasn't the same, but think of it as being where Ardbrett Castle is, and behind that, through the middle of the map, just on the right-hand side of the road there, you can see the grain of the countryside running through. The rocks layers are standing proud. So the development plan for this, through the Scottish Rural Development Programme, is to put on that natural woodland, native woodland. This is the scheme. The dark green colour is thick wood. The big red thing there is a deer fence. Well, that instantly kills what is prime training ground for next generation geoscientists is gone. Thank you and good night, because this is what it will look like. That's from the native woodland planting just down the road. Yeah, you try and map in that. Yeah, if you're an orienteer, that's called fight woodland. Yeah, you literally fight through it. You can't see the rocks, you can't move from place A to B. That's what you lose. If you haven't spotted the folds yet, that's where they are. Could you map that if wooded? No way. Lost resource for training. Now, it's not like there's not other places on that countryside you could put native woodland. But that site is not, it is in the Geological Conservation Review, but it's not a notified SSSI. Scottish Natural Heritage have yet to do it. Even though it's been identified for 25 years in the GCR, they've yet to notify that as an SSSI. And the planting scheme, that diagram was from a week and a half ago. So it could happen any day. They can't stand up and say you can't do it because they haven't notified it. Therefore, they haven't considered it important enough to notify. That is a huge threat. And it's happening across Scotland again. And it's happening across England as well. So as native woodlands put in. Don't get me wrong, I'm not against native woodland, but just put it in the right places, eh? But unfortunately, we need to get our own house in order as geologists. So here we have back in Pembrokeshire again, where a student party is walking out of the beach. What they've been to look at are these really neat structures, which are so-called conjugate shear zones, tension gas arrays, and you can from this work out which way the rock's being pulled and pushed. Really nice rocks. This is what they left behind. But I went there to take some photographs of some of the outcrops. This is what their staff did to it. And now you might think that's just chalk and it washes off, but actually it doesn't. It bleaches the rock. So the previous group's little arrow under there is still there. That rock is getting gradually devastated, and certainly from a photographic point of view. That's a bit daft. Let's go to another example. This is our student party, and I'm not going to have a go at our student party. This is on the Assynt Road section, quite close to the view I just took of the Ski Bridge woodland site, looking the other way. And what they're looking at is probably one of the greatest unconformities in Britain in terms of time gap. So you're looking at rocks on top there that are 1,000 years old. It's the Diabolic Formation of the Torridon Group. Underneath down in here, you've got Central Block Lewisian, last seen any kind of recrystallization 2.5 billion years. That's a 1.5 billion year time gap represented by that boundary, a really spectacular place. Something worth researching, but not like this, surely. So what's happened here is somebody wants to do some paleomagnetic investigation to get a timescale on this, and they've attacked it with a rock core. And they've also done it further on the section in here. That's outrageous. It's not an SSSI, it's actually not even the GCR at this site. But what it is on John Muir Trust land. John Muir Trust, probably one of the biggest conservation groups on the planet. They are somewhat grumpy that this has been gone on, to put it mildly. That's geologists defacing something of fundamental conservation product. It doesn't stop there. This is Scour. We've already visited this, so our students were working out the sequence of rocks in basement. Spot the drill holes. This is a notified SSSI. That is illegal. That is a crime, what has happened there. Literally a crime. Now, this is done for scientific research. The journals that have published this are effectively accessories to a crime. Let's be straight about this. Now, the good news is that actually things are changing, because ethics in publishing are getting a big deal. And this society, through its publishing house, and you may or may not be aware, but the publishing house here at the society is one of the major publishers of earth science in the world. In the last, well, actually 2 weeks ago, after a couple of months of lead-in, there's now a clause 5 says that all materials to be published here have to be based on samples that have been ethically collected. So that means if they're collected from any protected site, it's not going to get published. If it doesn't follow a coring code, which says you don't do it in the middle of the outcrop, even if it's not a protected site, you do it somewhere out of sight, it's not going to get published. So and other publishers are jumping in. I think this is a really big conservation win, because if researchers can't publish it, they're not going to do that damage. So thank you, finished. We've got to keep fighting. And interestingly, that code applies to anything published. It's not about whether you've done your damage in Britain. It's about anywhere in the world. Okay. So it means that we're actually, by proxy, protecting sites elsewhere on the planet. I think that's a really important win, and hopefully other publishers will come on board. It's being discussed this week in Geological Society of America, and it's going to be discussed in other publishers elsewhere. But let's end on a more positive note. Well, that's a positive note, but let's move up away from that a bit. So I thought I'd finish up by trying to explain again why outcrops are so important, not just professional, not just from a training point of view, not just from a practical point of view of providing better analogues for the subsurface. This is a trip run last year. It was celebrating the 125th anniversary of the Geological Society of America as a partnership with this society. Those are the people that came from 12 different nations, and they obviously came for the beautiful weather that you get in Northwest Highlands. And the reason is they went to see a whole bunch of stuff, but let's just do one little story that was about a day's bit of geology. This is a 1980s deep seismic line, a really important one, offshore northern Scotland. That's the Moho. You can see the little layers on top, which is the sedimentary basin of the West Orkney Basin, so just north of the north coast of Sutherland. And in the middle of the crust, you might just about pick out, I can't, there's this sort of grain poking up like this. So let's look at the outcrops that poke out at the top of it. There you go, up it comes. And you might think, oh, there's a sedimentary layering. Looks like sedimentary layering, looks like sort of flaggy stuff, the same sort of thing that Skara Brae is made of. So let's go and have a look. So here they are, off they go, here comes the gang. They're going to have a look at some of this material on this rather nice sunny beach again. You can see the heat stroke potential on some of the cars. And so what are they looking at? Right, well, actually, let's go and have a look. There you go. They're looking at this. It's roadkill pebbles. Okay, so it's a flattened conglomerate. That's everything flattened out, smack. So that layering was actually a defamation fabric. Everything's flattened out. Okay, let's go to another bit they're looking at. Here they are, the paparazzi in town now. And what's interesting about that slab are these, well, there you go, a bit more photograph. Ooh, what's that, mate? Oh, I'm not quite sure what's there you go, what do you think it is? Look at those folds, it's the polyphase deformation. Now there you go, so they're puzzling away. It's an outcrop Sudoku test. You try and work out where those folds go. Polyphase deformation, it goes round and round and round and round and round. So they're poultering that, and they step back and discuss it. Never having seen those outcrops before, they're not going to publish it. It doesn't mean very much anymore than it means very much to you doing Sudoku. But you're being inspired to problem solve. And then you can sit back and reflect and be inspired to do some more. So that's why we're going in the field most of the time. It's not to do anything particular, it's to be inspired. So I hope you'll go and visit some of these sites and also get inspired. Thank you very much.
That's been a wonderful tour de force, and I should go away thinking about roadkill conglomerate now, so I should go talking to my students and a host of other things. We've got time for some questions, and Rob's agreed to answer questions. And, if there are any from members of the audience.
It's the call of the one.
Perhaps I could just kick off then to get the mental juices flowing. You're commenting about the value of this for getting people to think, and we've seen all ages of people in the photographs there. Are you seeing increased numbers of people being interested in pursuing geology at various levels? Is that something that's new, or is it just something we're recognising for the first time?
Both. I think we're tuned up to go seeking out our audiences. So and also through the websites and all the rest of it. So we're actually seeing from the professional side, there are people who want to find out more, and I've been on Macaulay and Co on Radio Scotland this morning talking to there's people who want to find out, ring in about things. There's a general curiosity, and we can do a lot more to hopefully satisfy some of that curiosity. In terms, come back down through the game a bit, and actually in student numbers. So I on Monday will return. Actually, last Monday I taught our third year. Scotland's got a 4-year undergraduate programme. That's a junior honours year, and I'm teaching 135 people who are going to graduate. All being well, if they pull their finger out in the next year, 135 people who are going to graduate with a degree in geology from Aberdeen. Not a huge department. That when I first arrived in 2008, we graduated 45. Geology is a really, really, really healthy subject at university level, pretty much mapped everywhere. People are coming through the programmes. It's really good news. And in our case, they all get jobs. Mind you, we're in quite a good place for that.
Any questions come to mind while we've just heard that? Yes, please. Oh, there's a microphone coming just to help.
Hello, Roger Lloyd. I was very interested in the scathing comments you had about the guys who cored that rock. But on the other hand, you didn't mention the benefits that were derived from the analysis of that. Aren't you being a little bit unfair?
No. Bluntly, no. An ethical argument is never trumped by the good to anything. Just go and look at the history of medical research. You just don't do it. That you do not do research if it compromises the ethics, regardless of the benefit. Even if it brings a life-forming drug, you don't do it. It's just not what you do. In this case, it's to satisfy 5 people's curiosity. They might get 20 citations, and it's not that important in the scheme of things compared to a new drug. If the medical world don't do experiments on people who don't want to do it, who don't, if Burke and Hare were prosecuted for grave robbing for medical research, and that's dead people, probably, essentially next year's fossils. The medical community can have had their act together since the 1890s. Why on earth can't we? You wouldn't allow people to go to Stonehenge and drill great holes in it because we want to know for sure that it came from the Braccelli Hills. You wouldn't do it. So we have to look after ourselves. We don't pick wildflowers. You don't go and collect wild osprey eggs. You just don't do it.
What is the ethics of fracking?
Do you want to answer that question? No. Well, I don't know if anyone else heard the question. They certainly didn't hear it on the webinar here. What's the ethics of fracking? Fracking is. I mean, we have a history of extractive industries. I'm not against open cast mining necessarily. I think you have to be realistic that we as a society need raw materials, and that's fine. Fracking, in fact, is probably never going to get anywhere near the Earth's surface anyway, so it's not going to, in terms of outcrop geology, it's never, and let alone people's houses, it's probably not an event. But go to another exercise and go on the webinar about fracking that you can read because it's been covered in the last session.
What the chemicals are they use, they won't publish these.
Well, okay, that's a separate issue, though. And as I say, that it's been covered through, and also it's beyond what I was talking about today. There's equivalent session that we've had as part of the sessions through November, and I'd urge you to go and have a look at that.
Yes, there's a lot on our website about that, and the point about that is we're wanting to try to make sure that the facts that relate to the geology of fracking are there for people to see. And we know that at the Fellowship of the Geological Society, there are people who are opposed to fracking for all sorts of reasons. There are people who are in support of fracking for all sorts of reasons. So we're presenting the facts of the matter to enable people to make up their minds. So please have a look at the website and then do get back to us if you've got further questions, because we're very concerned about this.
Yeah.
There's a lady behind you with a question.
Thank you very much. I don't know anything very much about geology, as probably become apparent, because in that picture behind you, in the right foreground, it looks like a bunch of compacted rags. What actually is it, please?
The right foreground. Well, you've got student rucksacks there. You've got a dry stone wall that was created by Scottish Natural Heritage in the middle of their SSSI they're managing, and it's part of a rock sculpture system they've built across their site as part of the visitor centre.
In the middle, please, a lady with the glasses.
I was just going to ask about your use of Facebook, and not everybody's on Facebook, and do you think it's a really good way to assess, say, a country's feeling about their geological sites?
Um,
Or are you just getting a younger generation? Because I don't know how many people here use Facebook, but I think I don't.
No, but that's true. But in terms of, I mean, it's a bit of fun. It's not a. You're asking somebody based north of the border to talk about whether an electorate is representative or not. I think that in terms of whether 1,500 representative people who have an idea about geoheritage around the place, well, it's pretty good engagement by a learned society with the mass population. You can't really get a room with 1,500 people and put your hand up. So it's not a bad way to get going.
There was a question just behind you. And then we'll come across to this side.
That was an absolutely fascinating lecture, thank you very much. But I'm trying to get my head around the idea of learning about 3D mapping, and I wonder if you could sort of explain how you learn 3D mapping.
Well, it's experiential, really. I think unless you experience a 3D environment, you can't really know it. And some people pick it up quicker than others, it has to be said. And you can argue also that those of us who end up in those areas of the earth science that favour 3D thinking, which traditionally has been the structural geology world, self-select people, or don't self-select, but we tend to be concentrating that skill set over numerical skills, for example, or whatever else it might be. Some people do the whole lot, but not many. And it's an interesting thing about whether you could teach people things like that or not, or whether you're born or have that gift, whatever, if you want to call it like that. I honestly think you can. And some people come to it quicker than others, but you can do it. And eventually, let's be fair, I mean, in my city, I say my city, the city in which I live or outside of, Aberdeen's got way over 3,000 practicing geologists in it. That's practicing, not managers who've come through it. I suspect that 90% of those are working 3D data all the time. That's their day job, is sitting doing 3D interpretation. So that they've learnt it. Well, yeah, the quality of the job they're doing, discuss. It depends who shares you what to say. But they are doing that job. They've learnt it either through their training with us, or on the job, or just living it and building it all the time.
There's a question over here, then we'll come back over here.
Thanks for such an inspiring lecture. It's brilliant. I was just wondering whether the UK, you said, is is it one of the first places to really highlight these significant geological sites? Is there anything going on in the rest of the world?
Well, there's a bit of geology outside the British Arts. The fact is, if you wanted to cover this kind of, if you went to North America, you could see all this stuff. But your hire car charges, not to mention your carbon footprint for jumping on aircraft to do it is going to be staggering. It'll take, whereas you can do it. I mean, the story I would give, which I gave this morning, is that if you go to somewhere like Torridon in the Northwest Highlands and go for a walk up a hill around there, let's say Ben Alligan, you start off at the bottom of the loch on these 3 billion-year-old gneisses. You walk up the hillside over an hour or two, and you walk up through 1 billion-year-old Torridonian sandstone. You sit at the top, eat your Mars bar, and look over your shoulder, and you see sky. You see 55 million-year-old volcanics. You see a landslip in the Trotternish Peninsula that's fallen down because the ice moved away when it last moved out, I don't know, 50,000 years ago-ish. You've looked across the Jurassic of Raasay to see that. You look out across the Minches, an active sedimentary basin receiving the detritus today. There aren't many places in the world you could go and see that amount of geological time and those various processes. So it's, I think, you know, hey, we're really fortunate to be living here.
Are you happy that most of the places are rather obscure and places that people might go and visit, like Lapworth Cove or the Cheese Rings or something, aren't there?
Well, as I say, well, they are. I mean, the listing is the 100 great sites. The people's choice are the people's choice. So it's not us who put them up there.
Is it geologists' choice?
No, people. There's anybody who picked up. I mean, mostly not fellows of this society, for example. A lot of people voted, and from all over the place. And there's some pretty. I mean, for the coastal section, Hunstanton is not the most obvious. The best outcrop of Cresta is not the most obvious places. I mean, they're both relatively close to populations. I mean, firstly, I think Melvick Beach is probably a nicer bit of coast, but nobody lives in that Melvick. So I think it's actually pretty engaging. Lapworth is very much in there in the 100 sites. So we were clear that was there. So there are, and Westminster Abbey is there. The Thames Barrier is there. There are Highgate Cemetery is there. I mean, in this city, it's hard to do great landscapes and outcrops, but you've got a fantastic set of geology on the front of banks, in the buildings and memorials and so forth in the city. So if you want to look at rock types, probably one of the best places on the planet is this town.
Thanks.
The question right at the back behind.
Physical geology is fine, but why have you totally ignored fossils, in particular the Jurassic coast, the damage done by fossil collectors, removing fossils without any record whatsoever of where they got it, which strata, etc., etc.?
Yes, I'm not ignored. There's a limit to how much I can do in 50 minutes. And I agree with you. I mean, okay, a controversial point. I don't think we should collect fossils. I think it's very unfortunate we do it. The discussion that came up in the 3 o'clock lecture this afternoon here was the damage done by student parties running around with hammers. Well, for 20 years, I've not allowed a hammer on my field trips. You're not allowed to do it. I'm sorry. And it's a huge problem. And I think it's a big image problem with geology that we have a hammer as our symbol. I think that's outrageous. It's like having a broken egg if you're an ornithologist. I mean, the fossil point. I do not think that people should collect fossils. I think that's fundamentally wrong. You wouldn't do it with flowers. You wouldn't do it with osprey eggs. And picking them up off the broken beach if they're going to get bashed up by next year's storms, fine. But picking them out of bedrock, we shouldn't be doing it, frankly. And it's a shame. That's a partisan line.
Maybe make this the last question, please.
Okay.
If you wait for the microphone, please.
I thought it was an obvious question, Rob. What is your favourite site and why?
Well, I've got a number, but that's not bad. What you're looking at on the screen for the last 10 minutes is that what you're looking at there is across the Assynt Hills. I mean, the one around the corner, you can't quite. Actually, that's not probably it's going to get a really strange view. I walked up when I was 11 years old, and I've got quite an attachment with this landscape. It's actually sitting on Knockham Crag, is what you're looking on here. So you've got the Moyne Thrust directly underneath there that you can go and look at. It's got a visitor centre. I mean, there's all that stuff's there. I mean, actually, I do prefer the ones that are slightly more out of the way rather than the main road underneath it. And I'd ideally go to it, which is not covered in my students either, for a bit of peace. But I mean, actually, honestly, I think Arnable's probably my favourite. It's absolutely stunning and really world important.
Thank you very much for that, Rob. We'll let you off the hook because that's been a very wonderful discussion that's followed a most inspiring lecture. Only this morning I was talking to colleagues about the importance of field teaching of geology because we're in the happy position of following the trend that Aberdeen has seen trying to set up a new degree in Newcastle for Earth Science. So this whole point about engaging with students in the field and people of all ages in the field has come across so well. I felt really inspired by this. And I was particularly pleased to see my favourite location up there, the coast just south of Craster, which is like one of the most stimulating locations to go and do field work in Northumberland, even though it has got drill holes there that spoil a fold. But please join me to thank Rob for what's been a really excellent. I know some